Hi guys, this is your practice questions. Your booklet seems slightly different, but try to get on the same questions, and then onwards we have the same pattern of the questions here. Now, question number one, it says when particles of a mixture can clearly be seen. When you see something clearly, they form a heterogeneous um, is the answer. So if you want to know more about it, for example, you just want to know what is homogeneous and heterogeneous. So I just attach a table here, which probably can help you to understand that. So if you see the table here, this table can tell you something about the types of mixture, which is hetero or homogeneous here. And if you see the comparison is very clear, it is composition is uniform, non-uniform, it's just even particle distribution and uneven. You just need to go through it, and that can help you for the rest of understanding. When we go for question number two, if you see question number two, we say because helium gas does not contain any other element, it is considered. Of course, if it is no other element, it is means it's a pure substance. And a solid homogeneous mixture containing metal, which you know that is called alloy. And there's one thing you need to understand, that's the one only steel is an alloy of the metal iron and the non-metal carbon. Otherwise rest of the alloys are a mixture of metals. Now next one, question number four, if we say that, I think question number four say solid becomes what when all the molecules are evenly, so it means dissolved. So it dissolved when all the molecules are evenly distributed. Now next question is easy. You need to just basically use these words to just mention. So alloy is the answer for what the thing. Of course, you need to say homogeneous mixture. And then we go for muddy water. Muddy water is suspension, if we can see that. And the seawater simple is solution, and that's the answer. So now when we talk about the dissolve, what does a dissolve mean? So dissolve means we in something substance with the, let's say if I write substance, sorry, substance with similar chemical properties. Properties will dissolve in each other. I mean, such as polarity. The question comes to polarity later, but substance with similar chemical properties, they just dissolve in each other. That's called dissolves. Mean like, I mean, you can see that's the question next to this one. I already just left the diagram for you, so I don't have to spend much time on it. So see water molecule, and you can see we discussed many times here delta positive, which is hydrogen here, and negative is oxygen. So it means when in a compound, when elements are separated out because of their negative and positive partial charges, that's called we have polar or polarity. And now next go to question here. If we have it, for example, they're asking describe a physical way to separate mixtures. So I would say there are so many. Let's say filtration is one of them, and of course which can separate solid and solvent. You can separate easily solid and solvent. There are other methods also, probably I can mention that thing, which is distillation and evaporation, and they are probably magnetism and decanting. And these are the methods also use separate mixture. Now question number 9, you can already see that I think I already mentioned the formula here, which is the formula for molarity, which is number of moles of solid divided by volume in liter. So if you want to calculate molarity, so it means molarity is equal to number of moles given to me 2 divided by 0.8, and then of course when you use a calculator, I'm sure you get the answer 2.5 molar, which is the unit of molarity. Now here straightforward questions here, which is question number 10, which solution is heterogeneous? So it means you know this thing when you're doing the question number 1, I mean, which we did here, when we can see clearly be seen. So of course we clearly be seen here, this one, and it is not, light does not pass through. Now this basically image can also illustrate the Tyndall effect, which is the scattering of light by particles in a mixture. And if you see beaker A here likely contains a true solution, for example salt water, where the particles are too small to scatter light, so the path of the light is not visible. So it means beaker B here, it contains a colloid or suspension like milky or muddy water, where the particles are large enough to scatter light, making the light path visible. So it means our answer definitely is B over here, which is our heterogeneous solution. Now the question number 11 says the difference between saturated, unsaturated and supersaturated. I already mentioned here these things, so it's easy for you to differentiate. I mean, unsaturated, you can still dissolve more solute in it, and saturated point when that maximum amount of solute is dissolved, you cannot dissolve more solute in it. That's called saturated. And of course, if you want to use same saturated solution and you heat that, of course that can give you super saturated solution. Now question number 12 here, I mean, see, this is a graph given to you, and this graph you have questions here. The question number 1 or A part, which temperature does aluminum nitrate and potassium nitrate have the same solubility? So aluminum nitrate and potassium nitrate, you need to see that thing, which one is going for the same solubility here. So for that we have to go for the graph here, and you need to see aluminum nitrate here and potassium nitrate here, and when they are this brown line and the blue line, probably can say here, when they are meeting each other somewhere, potassium nitrate and aluminum nitrate, that will give you somewhere here, and that is roughly 55, I say, because each one 40, 52, 4, 6, 8, and it means 55, roughly I say 55 degree Celsius. And then we move on to question number B, part B, when we talk about 100 gram of potassium nitrate added to 100 gram water at temperature 50 degrees Celsius. So it means if we go for 50 degrees Celsius here and see what is potassium nitrate. So potassium nitrate is here. So 50, roughly I say 82 or 84, because I think the each square a 4. So it's 84 roughly. Or I can say precisely make it 85. If I can say make 85 here. So 85 gram I got it here per 100 gram. And then since 100 gram potassium nitrate was added to the 100 gram of water, so this is more than 84. That means you have added more than 84, which means this solution is super saturated. All right, and the last one, see how much more ammonium chloride could be dissolved if only 10 gram was added to 50 gram of water. So it means this is what you can do here. You need to find for the solubility graph what is 30 at ammonium chloride. So 30 degrees ammonium chloride should be somewhere 41ish, so 41 gram per 100 grams. So it means if it's 41 gram for right here, so 41 gram per 100 gram, which means that thing, since the solubility you can, they're talking about for 50 gram water, so it means what I can do, I can divide this 41 divide by 2, which is 20.5 roughly gram, and also because you added here what they say, you added how many grams of water, 10 grams was added. It means that thing you can add 20, you can subtract 20.5 minus 10, which is equal to 10.5 gram of water. Thank you.